Okay, welcome everyone. Hopefully you can hear me fine. And because we're out of time, I'm just going to start. I think some people are still coming in, but in any case, thanks for joining. If you're in the right session, you should be hearing us talk a lot about modern security operation. But first of all, let me do a quick introduction of who we are. So I'm a principal consultant at Mandiant, specializing in things like cyber strategy, notably everything around detection strategy. And I am joined by my colleague here.
Hi everyone, Maytha NASSOR. I'm also a principal consultant doing cyber strategy, focusing primarily on cyber defense. So everything SOC related, SOC transformations, it's what I've been doing over the last couple of years.
And as mentioned, we work at Mandiant. So Mandiant was bought 2 years ago by Google Cloud specifically. And Google Cloud at the time did not really have a sort of cybersecurity consulting branch, so that's what we became. And we're very proud to announce that in those 2 years that we've became Google Cloud security branch, cyber consulting security branch. We're now #1 in kind of leaders charts over there, so we're very proud to announce that. Quick note on what we do. Mandiant has been historically known for things like incident response and cyber threat intelligence. This is now moving a little bit towards things that are a bit more strategic or technical level assessments. So we have things like understanding the performance or the state of the cybersecurity program as a whole. We do it at the function level, different elements of the security program, and we also do it at the technical level, including things like security testing. So we've really grown in those few years. We're really expanding the spectrum of activities, spectrum of services that we offer, and that has kind of enabled us to gain an insight into where a lot of these different security function and security topics are going throughout the North American landscape, but also across Europe, like sort of EMEA and Asia. Now, with all that being said, let's jump into a little bit of context for today's session. The first thing I'm going to give you, and this might be a little bit hard for you to read, so I'm kind of going to go through it item by item. There's something that we've named the 10 plagues of cyber defense. These are kind of the 10 systemic or continuous issues that we keep seeing again and again and again in cyber, regardless of kind of the tooling or the transformation that happens behind. These are things that were probably already true 10 years ago and just continue to be true today, right? Just a little bit of terminology. By cyber defense, I'm referring to everything that falls in kind of like the monitoring spectrum, including detection and response. The first ones we have here on the top left in blue are going to be things like the lack of skilled labor, as well as the very, very high turnover rates that we have for security staff, notably in SOCs, right, security operation centers, as well as things like employee burnout. We're unfortunately in an industry where burnout is not even common. It's actually the most common issue that we have to deal with on a staffing basis. The second part that we have there in green is going to be everything to do with technology. Things like SOC tooling overload. Depending on the study that you look at, we're anywhere between like 42, I believe, to 72 average amount of security tools per company. That is unbelievable, right? That is too much tooling. That is a lot of things for analysts, for professionals out there to manage. On top of the technological sprawl, meaning like we have now much larger attack surfaces, much more complex attack surfaces, all that piping into the third one I have there, which is alert fatigue, right? Those analysts, those SOCs are being overloaded with alerts. A lot of noise, not a lot of signal. Finally, on the bottom row there, everything to do with process. I've been hearing automation as long as I've been alive. Unfortunately, it's still not something that has gone to the level that we wish it would. We're also dealing with incomplete visibility in most organizations, right? Most organizations will acknowledge that no matter the amount of logging that they do, they're still lacking. There's still sort of vague areas and so on. More importantly, we're also seeing continuous lack of business alignment when it comes to detection, right? The security monitoring programs are badly, if at all, aligned with business priorities. This is on top of the fact, as we see, of a dynamic, what I call a dynamic threat landscape, meaning attackers are getting faster. We see the global, the dwell time metric going down, meaning attackers are spending less and less time in the environment because they're faster and faster, and we have to keep up with that. Finally, all this kind of culminates or synthesizes itself, let's say, in the last point I got there, which is we are dealing with a cyber defense model, let's say, that's focused on reactiveness and not proactiveness. We're having a lot of the struggle, let's say, in moving current cyber defense program into a proactive state where they can do the right transformation work and reduce the load on their analysts. So that's it for the 10 plagues. Now I'm going to kind of give you the other side of the spectrum, which are the top 8 trends that we're seeing, or meta trends, meaning like these are trends that have been going for a while, and they kind of englobe a lot of sub-trends. The first one is very simply things to do with cyber defense models, right? Like zero trust has been around for about a decade now, but there's other models out there, such as the autonomic vision of security operation, and something that we also called CDCR, which, by the way, is going to be a core element of today's presentation: continuous detection, continuous response. Just going to use the quick metaphor of the elephant. If you have 5 people each touching an elephant, none of them have a good understanding of the whole, right? Like they don't really understand what they're looking at. Today's presentation is going to be kind of giving you the view of those 5 people and then bringing it together at the end into the elephant, which, spoiler alert, is going to be CDCR. Other quick trends I want to mention, things like services hybridization. Most SOC nowadays are not fully insourced, they're not fully outsourced. You're usually a mix of the two. And this is something that has been evolving in the last few years. Same thing with data-driven detection. We're seeing the rise of detection engineering and kind of all the new quantification and sort of scientification of detection. Things like automation as well that I mentioned before, kind of moving away from SOAR and low-code automation to more agentic security automation. Of course, new technology enabler, things like AI, who are essentially process accelerators, so they enable more value add per analyst hours. Things like changing architecture with the rise of data lakes for security, notably for hunting. And finally, just better testing and coverage analysis, right? Like most security programs nowadays do a much better job at kind of understanding where the gaps are and remediating those gaps in a timely fashion, but also something that we're going to cover later. Finally, all this kind of, once again, comes into this big one of threat-driven detection, something we'll touch upon again. This idea of operationalizing the pipeline from threat intelligence to modeling to hunting, right? Like making sure there's a pipeline working there, making sure there's a good understanding of threat-driven detection. So hopefully with those 2 slides, I kind of give a little bit of context on like what are the systemic issues and kind of like what are some key trends that we're observing. Now that that's been mentioned, we can sort of jump into the heart of the topic, which is modern security operations. So this first slide is going to be a little heavy. I'm going to go through it item by item. This is more of the table of content or like overview, let's say, of the rest of the presentation. First of all, let's define, right? Like, what do we mean? What is MSO? MSO, at the end of the day, is just an evolutionary paradigm, very fancy way of saying it's kind of the philosophy that we're seeing moving forward, developing when it comes to SecOps. What I mean by that is, more historically, most security programs are purely reactive, right? What we're seeing now, and as I've explained with the trends, we're trying to move into something that's not just reactive, but also proactive, right? Risk-driven, adaptable. We're trying to move away from things that are siloed, very like function-driven, like hard L1, hard L2, et cetera, to something more integrated, more, as we'll introduce, like DNR, right? Detection and response pipeline together. We're also trying to move away from things that are very like staffing-bound, very static, to something that's a little bit more data-driven and scalable. On the right here, I'm mentioning the genesis of principles that we're going to cover today. As I said, this is going to be a high-level discussion, right? We're going to be giving you kind of the intent, the direction, the journey. We're not really here to talk about sort of the low-level technical details. We're here to talk about the vision. We have three views, let's say, people, process, technology, as we all love them. In each of them, we're going to have 2 principles. So let's go through them. On the people perspective, moving away from siloed function mandate to something more skill-based in terms of staffing. Moving also away from very repeatable, manual or repeating work into something more higher value. And from a process perspective, moving from things that are very manual, very time-taking, require a lot of supervision and oversight to the opposite, right? Automation, unsupervised, and so on. But also moving from things that are intuitive, let's say, or ad hoc, to something that's a lot more data-driven, right? I want a justification for a detection level of performance. And finally, the last one, which is going to be technology, sort of moving further away from standalone tooling and functions to something that we name the unified DNR pipeline, the unified detection and response pipeline, sort of already an echo of what I was mentioning with CDCR, right? This is something that we're going to go into a lot of details later. And finally, the last one there, point in time or query bound, if you want to call it that way, to something that's more real time and more like continuous feedback. Continuous feedback being a big component of that CDCR cycle that we're going to talk about soon. So, as I said, this is more our table of content for today. I'm now going to pass it on to Maytha to kind of go through them one by one.
Perfect. So starting with people, I think we can all agree that in any security function or any element within our security program, people are really your greatest asset or your greatest strength. You can have all the tools, you can have all the processes defined, but if your people aren't skilled or if you're not empowering them, we're not really going to get anywhere. So MSO really embraces this at its core. Let's start talking about some of the challenges with current state SOCs. We're doing a lot of redundant tasks, unempowered analysts that are doing mundane kind of work, and they don't really see the bigger picture, right? SOCs are traditionally positioned as your operational function, but people don't really see them as providing significant value add back into the security program, and so MSO is trying to change that. When we talk about that first principle of embracing skills-based expertise, we're going to talk about two ways in which we're seeing kind of visionary SOCs do this. The first one is around building T-shaped expertise. I find a lot of times you have people in SOCs, your L1, you know, they're starting their trajectory in security within a SOC. They don't necessarily have expertise within particular domains. MSO is trying to move away from this to say, let's build skills-based teams that are focusing on particular domains within security. Right here, we've got endpoint, we've got network, we've got cloud, because how can I develop a detection about cloud-related threat when I don't really understand how cloud infrastructure works or the threats related to cloud environments? When we talk about L1 right here, it's really important to mention that specialization is not enough. When I say T-based expertise, you can have a specialty, so I can be somebody who specializes in cloud, but I also need to have the opportunity to contribute to tasks that builds my knowledge and my skill set across the DNR pipeline or the detection and response pipeline. So for example, if I'm a cloud SME, why can't I contribute to a hunt that is based on cloud-based, a hypothesis that's based on cloud-based TTPs or cloud-based compromise, right? So not only am I just focusing on response, I can also focus on hunts that enable my skill set within cloud. The second one is when we're going from this tiered-based model to skills-based, there's a heavy, heavy reliance on automation. You'll hear me talk about automation throughout the genesis of the principles. Automation requires us to make sure that we're cultivating some form of development skill set. When we talk about automation, we talk about scripting. It's not very easy without having the enablement to start coding or to do scripting, and so we really highlight and emphasize the importance of thinking about not just UI-based work, but let's move and start developing. When we talk about hunts, they're relying on things like Jupyter Notebooks. You can't do these things without having a foundational knowledge in development, right? This also enables your people to now focus on that more proactive kind of work, which we're highlighting as value-driven work. And when I say this, I mean, let's prioritize automation, let's prioritize engineering, let's stop thinking about our security operations staff as analysts and start thinking about them as engineers. When we talk about engineers, what do we really mean? We're problem solving and we have critical thinking skills and we're able to apply things to what we're doing. That not only enables us to free up work, but from a CISO perspective or leadership perspective, this means that we have more repetitive tasks. We have less error-prone manual tasks where one analyst is going to triage one way, our second analyst is going to triage it the other way, and they're not going to apply the same enrichment principles that are written in a static playbook that's defined on Confluence, right? We are trying to go for a trajectory of 40-40-20 between engineering, operations, and learning. I think if anybody here is managing a SOC, you can probably agree that you're probably spending about 95% on operations. Ideally, you have 5% learning, but other than your detection engineering team, nobody else is really focusing on engineering. Moving on, when you free up time, when you're doing things like automation, we're now enabling empowerment of our analysts. What that really means is, why are we not allowing the person who's responding to an alert to contribute back to tuning, right? Typically, you're going to say an analyst is only going to triage and respond, but they're not going to necessarily go into the SIM and actually tune the alert. There's that conflict of interest, etc. But let's not do that. Let's allow people to take ownership across your detection and response lifecycle, and then you have now more accountability, you have more ownership, and when you have context of what your service is providing on the other end, your opportunities for improvement are more informed by the other side. So if I know what it's like to respond to an alert, I'm going to try and tune it so that I'm not getting a garbage alert that has no context to enable me to actually respond. So now about our people, let's talk about optimizing the processes that our people are actually using. In SOCs today, a lot of redundant, siloed workflows with a lot of manual handoffs. We've got one person triaging an alert, they're going to hand it to somebody more senior, they're going to say, okay, I think this is malicious, can you make the determination if this is malicious or not? And there's a lot of lack of shared context from one team to the other, right? A lot of teams are working only within their specific mandate, and they're like, listen, that's the response team's job, or that's the hunt team's job. But I think if you're developing processes that enable a more unified and streamlined pipeline, as Thomas mentioned at the beginning, then you have improved efficiency, and it kind of enables your people back to that empowerment point. So when we talk about that first one, around the streamlined DNR pipeline, we're trying to take a threat-informed approach to detection and response. We can all say that a lot of organizations are saying, oh yeah, we apply threat intelligence and that's how we're determining our detection strategy. But how are you actually doing that? I'm seeing a lot of SOCs now come up with more repeatable processes to take the outputs of things like threat modeling to then say, okay, we know based on our threat profile, we're a financial services organization, these are the different threats, these are the different TTPs, but TTPs as a standalone don't really mean anything. How do I then take them and apply them to our critical assets, identify the gaps in our protective technologies, and then say, now I need to be able to detect this TTP, right? Now I say, okay, to be able to detect this, I know what logs I need. We move on to the second point here is we need to move away from manual deployment of alerts. We need to stop doing things within the SIM solution, drag and drop, etc., and start thinking about our detection and response content as code. We've probably all heard DAC, detection as code. What does that really mean? It means that we're thinking about our detection and response content as artifacts of the software development lifecycle, tying back to that concept of cultivating development skills. I shouldn't be manually developing things in the SIM. I should be doing things in a version-controlled repo that can directly be uploaded into my SIM solution and have a CI/CD pipeline doing the automated deployment, the automated testing, instead of doing things manually, right? But once you actually identify and you deploy these technologies, a lot more of the mature organizations are also integrating continuous validations into their pipeline through emulation of TTPs. This is not something that less mature organizations are doing. I'm not going to try and say everybody can do this, but we need to move beyond just testing the logic of our detections. It's very easy to say if X and Y, then trigger, and you can test that, right? You can set your variables to X, you can set your variable to Y, and it's going to trigger. But how do we make sure we're actually detecting attacker behavior? Because attackers don't just work on one particular TTP. There's going to be a set of TTPs, they're going to go through an attack path based on intelligence, and that's what we need to be able to detect instead of siloed events that are obviously going to alert. So that's what we mean by continuous validation. With all these processes, with everything that people do, data is going to be your biggest asset. I think I've seen a lot of organizations develop metrics and programs when it comes to metrics in these siloed teams, but we're not really thinking about how can we apply these metrics holistically, and the gaps that our incident response team finds should really directly be informing changes in our controls, right? If I continue to see an alert around privileged access or an alert around unauthorized software, clearly I have a gap in my application allow listing process, or I have a gap in my identity and access management controls, which we should be looping back into our security program. When we talk about building integrated feedback loops, I think I'll use a very concrete example of detection acceptance. Traditionally in SOCs, you have somebody developing a detection, and then it just gets punted over to the IR team or your L1 team to respond to. Why don't we, in our process of detection development, make sure that our SOC has a way to say, we are operationally ready for this alert, not only based on the alert fidelity, but also based on how long is it going to take us to triage this alert. If I'm noticing that I have a high fidelity alert that's taking 10 minutes to respond to, this is a clear opportunity for somebody on the response side to say, maybe this is an enrichment opportunity, because detection engineers are not thinking the same way an analyst who's responding to things are. So this is what we mean by making sure you have processes that are integrating feedback, taking the skill sets across your SOC. Whenever we talk about data, SOCs, a lot of L1, L2 analysts, they're nervous, they're scared to make mistakes, and that forces them to continue to escalate. I don't want to make the call on whether this is malicious or whether this is benign, so I'm going to rely on my colleague and I'm going to escalate it and just assume that they're going to detect it. So with that being said, modern SOCs, we need to continue to bring forward a culture of growth, and that requires blameless postmortems. It requires realizing that failure is an option. It's okay to realize that we should have other compensating controls that don't mean if I triage something as benign and it is malicious, the entire company goes down. We can't rely on one single function to respond to everything and to keep our company secure. Technology always goes last because technology is an enabler of your people and your process. When we talk about harmonizing your SecOps stack, Thomas kind of mentioned this, we need to try and take a platform-centric approach where we're unifying our SIM, we're unifying our SOAR, so I'm not, as an analyst, having to jump from my SIM to the SOAR to the EDR to try and understand what's going on. If we're going to tell our SOC that a SIM is going to be their single pane of glass, make it their single pane of glass. Otherwise, they don't have the data, they don't have the information to make informed decisions on whether something is benign or not, right? The other thing about this is it also helps with this streamlined response. I can trigger a containment action within the same platform. That makes it a lot easier, and this is heavily reliant on API integrations, right? A lot of security technologies have containment capabilities, but we're not leveraging them because we're not connecting them to the single pane of glass that's actually detecting malicious behavior. When we talk about the last one here on integrating workflows, I'll give a concrete example here. If we're going to go from Jira, where we're going to track the planning, the development, the implementation of a detection, I should be integrating directly with GitLab that's going to store my detection as code. GitLab should be directly integrated with my SIM, so now I have a unified pipeline not only to measure capacity and the workflows that people are working on, but I also get rid of these inefficiencies of having to go to Confluence, having to go to Asana, have to go into Microsoft Project, all across different platforms. This goes back to this unification and integration with the CI/CD pipeline for more efficient deployment of our detection and response content. This wouldn't be a security presentation in 2024 if I didn't have the word AI in it. So I'm going to talk about leveraging AI enablement. AI is only as powerful as the use cases in which you define it for. If you use it for something that doesn't make sense, then you increase the risk of what you're using it for, and humans always have to make informed decisions based on what AI is outputting. So I've got kind of 3 different use cases for the use of AI here within SOCs. The first one is enriching data. We've seen a lot of UEBA tools that are leveraging AI for more predictive analytics. Take advantage of adding more context to your data, adding more context to the logs, to your detections, to enrich things so that your people are actually making decisions based on all of the different data that's coming together in one single pane of glass. A lot of SIM solutions now have the capability to go from a human query to from human language to an actual SIM query, saying identify the number of times this IP address showed up in the firewall in the last 24 hours. It'll tell you your answer instead of having to sit there and fight with queries, ensuring that you have a semicolon. The last one I'll quickly touch on is just talking about leveraging it for responsiveness. A lot of organizations are scared to use containment in general, but there's a lot of opportunities and integrations of AI capabilities in SOAR solutions that really make a lot of informed decisions for you, and then you obviously have to validate, but this is what we mean by real-time responsiveness. Let's not delay things, and let's try and take advantage of being able to leverage these smart models to make proposals for us. So as Thomas mentioned, this is our elephant. Continuous detection, continuous response is what CI/CD is to the software development lifecycle. When I traditionally used to think about SOCs, I used to think about everything in silos. Detection engineering, your threat hunting, your threat intelligence, your L1, L2, and incident management, and that's how I used to think about the different functions or your service catalog of a SOC. CDCR tries to say the way you think about CI/CD can be directly applied to how we do detection and response. Let's start with data visibility. This is how do I make sure I have the right logs? How am I making sure I have the right detections? And that's directly, the output of that is directly informing your capabilities for analytics. When I say analytics, I'm talking everything about hunting, detections, actually triggering, the enrichment that we're doing. If your data visibility is garbage, your analytics is going to be garbage, right? We then move on and we talk about response orchestration. Response orchestration is completely dependent on your ability to analyze and make meaningful insights. We can't contain things if we don't have confidence in our analytics capabilities. And tying back on that concept of a data-driven culture, that green continuous feedback is where I continue to see organizations struggle. You have teams that are not sharing information. You have no shared context across your SOC. Everybody's doing their own thing. So that continuous feedback is what brings this entire infinity symbol together and enables us to make sure that the output of our case management, the output of our threat hunts are enabling our data visibility to improve. Because if I know that I have a visibility gap based on response, I know that now I need additional log sources within my SIM solution. So just kind of tying it all together, this is our presentation on modern SOCs. As Thomas mentioned, it's kind of a philosophy, it's kind of a vision. It's not necessarily a target state. It's helping organizations think about security operations differently. If you have any questions, happy to take them now with 1 minute that we have. Otherwise, Thomas and I will be kind of standing around and happy to talk through anything that we talk through. Thank you.